In this video we will show how to work with Tangra GeoMagne Radar by Tangra metal detectors. Before we start working, we need to switch the device on, and then we need to start the Android application. We need to tap on the application's icon, which is on the screen of the tablet. After we have started the application, we need to establish a connection between it and the device by tapping on the icon with the red human figure at the top left corner of the screen. The connection between the device and the tablet is a Bluetooth connection. Sometimes, the connection fails to establish at first attempt. That is why we tap on the button with the Connect sign on it, until we succeed. When a connection is established, the blue LED of the device would go bright. After the connection between the device and the tablet has established, we may continue with the adjust procedure in order to calibrate the device for our task. In this procedure we need to adjust both sensors so they could show readings as close to one another as possible. In order to do this, the user needs to stand still at the closest rightmost end of the researched area. With the device in still, vertical position, the user needs to turn the device's potentiometer left or right and observe the readings from both sensors shown on the screen, until they become as equal as possible. First of the three numbers shows the readings of the top sensor. The second number shows the readings of the bottom sensor. After we adjust the readings from the both sensors, we may continue with exploring the terrain while we are in the current adjust mode. In adjust mode we can explore the area by walking around while observing the changes of both senses and changes of the 3 lines on the screen. When the sensors readings change and both lines move up or down, this indicates presence of underground objects which affect the magnetic properties of the current spot. We have to say once more, when we work with the device we need to keep it upright vertical, otherwise the readings will not be accurate. Also, the device need to be kept at all times oriented as it was oriented at the beginning of the survey. In adjust mode we may observe and detect the smallest changes of the sensor's readings. In order to suppress the audible warnings for small changes, we may change the range of readings that we do not need to be warned about. There are 2 adjusting buttons on the right side of the screen which we may use to change the "No Warning" range of readings changes. By pressing the 0 button on top of the device, we inform the program to consider the current readings as a base and referential for the following readings. Now that we have calibrated the device's readings, we may proceed with making the map of the explored area. We need to tap on the Ready button and thus we inform the program that we are done with calibrating the device and the adjust procedure has ended. Now we may proceed with choosing the size of the map for our survey. The size of the map should be chosen according to the real size of the explored area. We may choose the size of the map by tapping one of the size buttons on the left side of the screen. The sizes are 6, 10, 20 or 40. In our case we choose a map with a size of 20. This means that during our survey we are going to get 20 rows by 20 readings, or 400 in total, for our map. We choose the size of 20 by tapping on the button. Before we start making our survey map, we need to make sure that the device is upright vertical, closely positioned to the ground surface with sensors readings close to one another, adjusted by using the potentiometer. We press the 0 button and inform the application that we are ready to start making our survey map. At any moment of the survey we may choose to acquire data manually or automatically. We use the Run and Step buttons for this purpose. When we tap on Run button, the application starts automatically acquiring data each second. When we use the Step button, the application acquires data each time we tap on the button. During our survey we may choose to use different ways to observe the acquired data and see the results on the survey map. The result of our survey would look this way. We use the button with the sign of an eye on it at the bottom of the screen in order to switch between different visualizations. We already saw one of the visualizations during the adjust mode. At the end of each row of our map we need to change direction. It is very important to keep the device vertical and constantly oriented the same way at all times, as at the beginning of the survey, despite the change of walking direction at each end of the area. The best practice is to keep the device facing east at all times. Again, at each change of walking direction, the device must keep its original direction as it was at the beginning of the survey. Now we proceed with collecting data along the second row of our survey map. Now we can see changes on our map caused by detecting objects under the surface of the terrain. Here we change walking direction again. Still, we keep the device's orientation unchanged. We walk along the current row and observe the changes on the map. We need to say once again. During automatic run mode we need to keep same and constant speed in order to each time finish at the end of each row. During the survey, the user may choose which one of the three visualizations is most helpful for their task. We use the button with the sign of an eye on it at the bottom of the screen in order to switch between different visualizations. Let us see again how is one map being made. First, we need to choose the size of our map according to the actual size of the explored area. From rough 6 by 6 to fine 40 by 40. We need to tap on a button selecting the desired size of the map. The buttons are shown on the left side of the screen. We tap on button 20 and choose a map with dimensions 20 by 20. At this moment the application shows an empty map and expects us to start collecting data. We can start collecting data by using one of the two buttons on the left side of the screen, Step and Run. Tapping on Step button we choose the moment when we acquire readings for a certain place of the map. When we tap on Run button, the application starts collecting data automatically, one reading each second. Once again, the best practice is keep the device vertical, face it towards east and keep it this way during the whole survey. Not complying to these recommendations leads to incorrectly acquired data and worsens the results of the survey. Also, when the device is not vertical within certain angle range, the device warns the user. Having the device inclined beyond 15 degrees from its vertical position is leading to showing a warning sign on the screen. Acquiring data with an inclined device gives highly undesirable results. As mentioned earlier, the buttons Run and Step cause the application to acquire data from the sensors and puts them on the map. At this moment we are using the Step button in order to manually select the moment of data collecting. When we wish to automatically collect data, we need to tap on the Step button and the application will get data on each second. Here we see dots with different colors, which represent different values of the strength of Earth's magnetic field changed more or less by the objects under the surface. Each time we reach the end of a row, we need to change direction. However, do not change the device's orientation at all times, and most importantly, at the end of each row. Once again, we may walk through the different visualizations of the map. We may do this at any time of the survey, if it is of help and does not disturb the data collecting process. This visualization shows the map of the survey in its final view, as it will be stored at the end of the survey. Now we may proceed with collecting data for the second row of the survey map. Now we tap on the Run button and walk along the row. During collection of data, we may change visualizations, if desired. We choose a visualization which is most helpful and shows best the map being created. We may tap on Run button in order to proceed with a third row of the map. Here we are going along the row until we reach its end. At each end of a row we can see the current map better and better. We may tap on Run button in order to proceed with the next row of the map. At each moment of the survey we may switch between the three different visualizations. Also, we can see the 2D and 3D visualizations of the map at the end of the rows. By pressing the 3D button, we proceed with seeing the 2D and 3D representations of the current map. We wait until the two representations are prepared for viewing. Here is how the 2D representation look like. We wait until the bottom left button turns green, indicating that both representations are ready to be viewed. Now, we may tap on the green button and switch between the two representations. In 3D representation, we may slide a finger over the screen. This way we rotate the 3D image and look at it from different angle. Also, there are two buttons for bringing the image closer or farther for better viewing. Again, switching back to 2D representation is done by tapping on the bottom left green button. In 2D representation, we may slide finger over the screen and see the exact values of data collected during the survey. These values are shown at the top left corner of the screen. Here we got a local maximum. Here we got a local minimum. Back to 3D visualization. In order to exit 2D 3D visualization, we need to tap on the long yellow button at the bottom of the screen. From this moment on, our task is to collect data for the rest of the map. Here we see another changes on our map. Again, we need to change direction and continue with the next row. We need to remember not to change the vertical position of the device, as well as to keep its orientation. Tap on Run button in order to continue with the next row of the map. We see no data changes at this particular part of the row. We change between the three different visualizations, if it is more helpful or informative. Now we switch to the visualization where we can see both sensors readings and their difference. Note that sometimes there is no difference between both sensors readings, but they may change. That means there are changes of the current spot's magnetic properties. Once again, we need to remind that the device needs to be kept upright vertical, without changing its orientation and its same distance from the ground surface. When we do not keep the device vertical, we may get incorrect data from the sensors. Now we intentionally incline the device and we get warned about this. This would cause an incorrect and misleading representation of the inspected area's properties. This unwanted behavior leads to deterioration of the data and the results of the survey. Again, we intentionally incline the device and we get warned about this. We need to always keep the device upright vertical, oriented towards east, keeping same distance from the ground surface. Switching to the simpler 2D visualization. Switching to the visualization with the two sensors' behavior during the scanning. We observe the sensors' readings behavior during along the scanned row. Here we have some changes of both sensors' readings caused by some objects beneath the surface. We continue with the next row of the map. All these changes will be shown on the map. We can see these changes by switching to another visualization. One last row of our map. At the end of the row we can see the final view of our map. We tap on the 3D button and wait for the 2D 3D visualizations to be prepared. This is how our map looks like at the end of a survey. Switching between 2D and 3D visualizations by tapping on the green bottom left button. Slide a finger over the screen in order to rotate and observe the map from different angles. Tap on the long yellow button at the bottom of the screen in order to exit 2D/3D visualization mode. From this moment on, we may continue with creating the map until we are done. When we finish this row, we will finish making our map. Now we will see where the results of our survey are stored. We need to exit the application. We launch a file manager in order to find the stored files for our survey. On the left side of the screen, tap on Device. Tap on Folder Android. Data. GeoMagne Radar. Files. Here we see several folders named after the date they have been created. They all contain data files with results of previous surveys. We enter the folder containing our last survey. Here we may see a picture as a result of our survey. We exit the file manager. The GeoMagne Radar application also can visualize the results of previous surveys. The files, as we said before, are stored in the internal memory of the tablet. In order to view them, we start the application again. We need to tap on the folder icon at the top of the screen. Here we see folders containing data of our previous surveys. We enter the folder with our last survey. Now we may choose particular map by tapping on PNG 3ds file. This is a map of an unfinished survey. Tap on the long yellow button to exit. Again we enter the file visualization mode. Let us see the final view of our last survey. Again, we may choose particular map by tapping on PNG 3ds file. We choose to view the map of our last survey. Tap on the green button at the bottom left part of the screen in order to switch between 2D and 3D visualizations. We exit the visualization mode. This is the end of our presentation. We may now exit the application. Thanks for watching.